Well, hello everybody, welcome back. We're going to do problems number 20 through 25 now. And so we're starting out with scale factors. And scale factors are when we have similar triangles, there is a ratio between the two triangles or two shapes that make these guys similar to one another, so we can set proportions and set fractions equal to each other. So if I want to find the scale factor of this pair of triangles for A here, I have to pick two sides that I know the numbers of. And it didn't tell me whether I want to go big triangle to small triangle or whatnot. So the scale factor between these, I'm going to take these two bottom sides here. They look like because it's angle similarity. Because it looks like the way they're marked the same. So I'm going to take 4 and divide it by 2 because those are my two common sides. When I reduce that fraction, it is 2 to 1, so that becomes my scale factor. So that means if I take this smaller triangle and multiply it by 2, I will get the larger one. If I take the larger one and divide it by 2, I will get the length of the smaller one. And so now I use this scale factor in order to find x. Since the triangles are 2 to 1, big triangle to small triangle, that is equal to, if I wanted to find x matches up with the side of 9, so it's going to be 9 to x, big to small. And the convention that we use to figure out what x is, we do a little cross multiplication here, which gets me 2x equals 9. And when I divide by 2, x comes out to be 4.5. And so that should make sense because I said the bigger triangle is double the smaller one, or the bigger one is half. If I take it in half, I get the smaller one. If I take 9 and divide it by 2, I get 4.5. All right, so let's figure out the scale factor of these two triangles. These two triangles are similar because of angle. They marked these two angles the same, and they marked these two angles the same. So therefore, they are similar to one another. So what we're going to do is I'm going to go small triangle base to big triangle base, and when I reduce that fraction, I get 2 over 3. So reducing that fraction gives me 2 over 3, so that is my scale factor, and that scale factor is what I will use to find x. So the two sides are 2 to 3, so I'm going to say 2 to 3. Those are my bases. That's going to be equal to, well, the smaller triangle is 8, and the bigger triangle is x. And the convention, remember, that we use in this one is to cross multiply. So I'm going to say 2x equals 24, and if I divide by 2, that will leave me that x is 12. All right, so moving along, we need to decide whether these triangles are similar and how we know. Well, if I do a little rotating, this angle K will match angle U, and angle J will match angle T. So we have enough to prove that these triangles are similar to one another. And so these triangles would be similar by angle similarity, just like the two above. And so now how are these matching up? Well, it's KJL. So J is the single marked to the double marked angle to the no marked angle. So if I do that same order for this one, then the triangle that JKL is similar to would be single mark T, double mark U, and then V is the unmarked one. So those are that's how the triangles are similar to one another. All right, moving along here, question number 22. They're asking me they're talking about congruent, and remember that the order of these that they tell me these triangles are in are important. So things that match up when we're congruent is the first angle would match up with the first angle. So angle X will match angle P. Angle Y, middle ones would match, angle Y and angle Q, and angle Z and angle R, the last letters, will match up. All right. The next thing that we talked about with congruence was, can we prove triangles congruent to one another using our properties? And remember, we had 4 of them. We had side, 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 angle, 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 side, and then the weird stepchild one that we never had was HL that we had floating around that we hardly ever used. That was when we had a right angle. You had to have a right angle to make this one work, and if I'm looking at my 2, I don't have them. So we're talking about this, that we have these two. If I try to line these triangles up, it looks like this angle here is between the two sides, and so that looking like side angle side, but you'll notice that these two two over here don't match up, and so we're missing this angle right there. So these two can't be done by side angle side, and so these two triangles are not congruent to one another. There, it doesn't match any of these guys over here. And over here on B, we have two angles congruent. We have the two, if I've kind of folded along this line would be the reflexive side. And so, and therefore, we have an angle and an angle that match. And if I folded this angle would line up with that. So it looks like we have two angles and a side. So that would be the third one here, that these are congruent by angle, angle, side. And so then the last thing that we did was writing proofs. And so we're trying to prove that triangle MNP is congruent to triangle OPN. So we're trying to prove these two triangles congruent, and they gave me some information. So I'm going to start out. We always start out by writing our given information, that angle MNP is congruent to angle OPN. That would be our given. And so I'm going to do this as a two-column proof. Looks like this. This is our statements. And over here is reasons. And then, so step 2 would be write down the other given information. And if they weren't already marked on the drawing, I would be marking them on the drawing as well. MN is congruent to OP. And so over here, that is also given. So then we have one angle, we have one side and an angle, a side and an angle. So looking back up here, sides and angles, so we can't use side, 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 and we're not going to use HL because that's not a right angle. So we have these three choices, side, angle, side, angle, and angle, angle, side, as my three choices. And so now I got to decide what's the easiest thing that I can get. Can I get two sides equal to each other? That would give me either side angle, that would probably give me side, angle, side. And so that's what I'm going to look for. And if I'm looking at my drawing, you may notice that NP here is a reflexive side. It's in both triangles. So if you remember this one, we can say that NP is congruent to NP because that is reflexive, the reflexive property. And so the reflexive property tells me that those two pieces are equal. So now if you notice that I can talk about this triangle MNP is congruent to OPN because they have two sides that are congruent to each other, two pairs of sides that are congruent to each other, and an angle in between. So I've done enough at this point to prove that these triangles are congruent, and I can say triangle MNP is congruent to triangle OPN by two sides and an angle, and the angle happens to be between the two sides, so we call it side, angle, side. All right, the next one over here, number 25, we are trying to prove, sorry, let's scooch back up here. We're trying to prove that the triangle ABC is congruent to triangle EDC, and we can do this again. We'll start with writing down our given statements, so let's get this set up here. We have our statements. And we have our reasons. And so step 1, my statement, I'm going to write down that C is the midpoint of AE. C is the midpoint of AE. That was given to me. Then I'm going to write down my next given statement, that BA is congruent to DE. That was also given. And I'm just trying to get the easy ones out of the way here. Step 3 says angle A is congruent to angle E. And I would be marking them on the drawings up there if they weren't already marked. So this guy was also given. So if you look, angle A and angle E are congruent. And they also told me that this side is congruent to that side. They told me that C is the midpoint, so by knowing that C is the midpoint, C is in the middle of A and E, and being in the middle means that we're directly in the middle, so it cuts this AE into two equal pieces. So that would be my next step, is that I'm going to say AC is congruent to CE by definition of midpoint. And I wouldn't use bisector because they told me up here that we're using a midpoint. If they told me C was a bisector of AE, then I would say by definition of segment bisector. But I don't have to because they told me midpoint, so I'm going to go with that. So now that I know that AC right here is equal to CE, then I have enough information to prove that these triangles are congruent to each other. So finally, I could say that triangle, what was it, ABC, is congruent to triangle EDC by, well, it looks like I've got two sides and the angle in between, side, angle, side. So this concludes the video for examples 20 through 25.